Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessment, and today we are going to look at EIA methods pertaining to the domain of noise, and in that we'll be looking at the concept, scoping and baseline study. So accordingly, our coverage will include, we'll first look at some of the basic principles of vibration, we'll look at the basics of acoustics, then we'll see how measurements are done for various noise characteristics, then we'll look at factors influencing noise impacts, like how is the impact and how does it varies depending on what factors. Then we'll look at scoping and baseline studies, how are they done when we deal with noise impact, and how do we do impact prediction, and how do we undertake evaluation, what kind of calculations are done, what modelings are available, and how do we assess significance of any impact. So the learning outcomes expected from you after completion of this session is that you have to define certain terms related with it, like vibration and frequency, sound, and so on, what's noise, and so on. And then you have to determine basics of acoustics, which will have implications on EIA. And you would be required to identify different measurements for noise characteristics. You should be able to review different factors that influence noise impacts, and you should be able to identify key elements of what you really do within scoping and baseline studies, and then you should be able to undertake impact prediction and evaluation, at least understand the theories behind it, and you should be able to decide which calculations to use, what modelings to use, and then you should be able to undertake significance assessment as well. So the basic course book for this is what we are following is Tharrell and Wood's book on methods, so we are constantly referring to that. So when we consider noise, we see that almost all the projects have noise impact, and noise during construction may be due to activities such as you might be doing land clearance, you might be doing construction, the piling work, and then the frequent transportation that takes place in and around the site. So all that leads to noise, and we have seen many of this noise related legislation. We have also seen certain environmental conditions also related to that. So today we'll just focus on some of the limited definitions, and then how we undertake scoping, baseline, and impact prediction and assessment. So noise is like a major and a growing form of pollution, and we had already seen WHO guidelines in that. Looking at the basic principle of vibration, so what is vibration? Vibration refers to the oscillation of an object about a reference point. So with what number of oscillations per second is happening, and that is given in form of frequency of vibration. So there is a difference on how vibration and sound are experienced or sensed by humans, and where we see that sound is detected by hearing. We hear the sound, whereas the vibration is felt as it is transmitted through the structure, the solid structure, directly to the human body. So something which is coming from we are receiving from the ear, and then something which we are receiving or feeling it at the entire body. So vibration can occasionally occur at single frequency, and then there are like also usually it is seen at several different frequencies. So vibration frequencies between 1 to 80 hertz are perceptible to humans. So we perceive that, and then the particle may vibrate vertically, longitudinally, and horizontally as well. And it involves this. Often it is like combination of all these three: vertical, horizontal, longitudinal, and it's. And generally, what we see in EIA is that it is quantified, this vibration is quantified, and it is given in terms of peak particle velocity, PPV, and it is measured in millimeters per second. MMS is given, MM by S is given. So that is how you refer in EIA report. And if you look at the threshold of human perception of vibration, the range is from 14 mm by S to 0.3 mm by S peak particle velocity, PPV. So usually you see that road traffic, railways, they are the common source of vibrations. If you have ever lived next to the road, you might realize when heavy vehicles move how you feel the vibration, or living nearer to the railway track. So you would have a sense of what vibration is like. So usually you do not get complaints from many of the vibration project, but it's usually when you get the vibration where the complaints are usually raised are mostly concerned with vibration transferred through air. And then you also find standards like BS 52282 standard, which also indicates like various construction activities and which activities cause vibration, and these can be referred there. So looking at what is noise, what's the fundamental concept behind noise? So noise is something where there is a sound which is unwanted. So unwanted sound is said to be noise. So the key point here is that what is unwanted can be very subjective. So the key understanding here when we define noise is that it's very subjective to how people respond to it, and irrespective of the objective reality, like what's the actual intensity of the sound, irrespective of that, how people respond to that particular sound is what makes noise. So the physical level of noise is not really some like measurement of noise. It will vary with how each one receives it. So for that matter, you might be in among the concert. So what kind of noise level is there? Where you're close to the airport. What is good for you? Many would be happy next in the rock band, whereas the neighbors around the band going on might be unhappy with the same level of sound. So we need to understand these differences. And then when we do undertake noise impact assessments, we really look into quantifying and having a very objective understanding of how people are going to respond to that particular sound. So we try to understand, or when we say objectify, that means having a consistency across all the receivers, and then giving a quantity, a value to that response. So if you look at sound, so sound consists of pressure variation that are detectable by the healthy human ear. So sound is said to be the pressure variation which we can hear. These pressure variations have, like you see that they have two main characteristics. One is frequency and another is amplitude. So sound frequency refers to how quickly the air vibrates. or how close these sound waves are to each other. So that in cycles per second, which is also set like hertz. So you see that's sound frequency, how quickly the air vibrates in any particular sound. So frequency is felt subjectively as the pitch of the sound. So frequency is subjectively felt as a pitch of a sound. So when you feel it, it's more of a pitch of the sound. And lowest frequency, which is audible to human, is approximately 20 hertz. So we can hear to that, and the highest is 20,000 hertz. And when we talk about environmental noise, it's majorly about particular frequency or certain broadband, and it's like comprising of range of sound of different frequency. So in the environment, if you see, you might have like industrial area, you might have turbines, you might have compressor, you might have fans, huge fans, and you might have transformers and all these things, which might all add up, or may give sound of different frequency and all add up. So that would be the environmental noise. And that would also lead to the total noise. And how do you really work out the total noise? So the total noise is usually more like you are aware of total noise more in any situation. And when the total noise exceeds, you make note of that, and you get irritated or annoyed by that context. So there are range of frequencies, how these things are worked out, and you have sound level meters, which can like really capture sound of different frequency, and also give you information on environmental noise. So when we talk about sound amplitude, so then we majorly we refer about the amount of pressure. So when we are saying sound amplitude, we are referring to amount of pressure which is exerted by the ear. So which is often visualized as the height of the sound waves. So amplitude is described in units of pressure per unit area, micropascals. So that is how you refer it. So sound amplitude, where you capture it by amount of pressure, and it is indicated by micropascals. So the amplitude is sometimes converted to sound power. So another term which you'll many times come across standards is sound power, which is in picowatt, 10 to 12 watts, or sound intensity, which is like 10 to 12 watt per meter square. So you would also see amplitude. So sound intensity is like subjectively felt. So it's like it depends on the receiver. So and it is like said as the loudness of the sound, how loud it is, and so it is really indicated in form of logarithmic scale of decibels. So you indicate in log decibel. That is how it is represented, sound intensity. And you also have sound pressure level, which is LP. In decibels, it's given by, like you can see, LP equals to 10 log of, you can see this, P, capital P by lower p square decibels. So here you see that P is the amplitude of the pressure. So we talked about the amplitude of the pressure fluctuation which happens, and small p is the micropascals, 20 micropascals, and 20, we take this number 20 because it is considered as the lowest sound audible to the healthy human ear. So the sound intensity level can also be described, like you can describe it as sound power, where you indicate it by W, and it is indicated as 10 to 12 watts. So a sound power level, which is like LW, is the energy output of a source. So how much energy is coming out from the source, and it's calculated from measurements made around the equipment. So wherever the equipment is placed, the source is there. So you measure around that carefully in a very controlled condition. So usually, how do you get these values? So the manufacturers of the equipment, they usually provide these LW sound power levels. So that's provided to you. So you can use those information to assess these noise impact, to undertake these noise impact calculation. So there are certain frequencies for which the human ears are much more sensitive, like 1 kilohertz, 2 kilohertz, and 4 kilohertz octave, and much less sensitive at the lower audible frequency. So if you see most of the sound analysis which is done in EIA, there your major focus is on the loudness experienced by the people, the receivers, and more than actual what's the physical magnitude of the sound. So how the receiver respond is key to EIA process. And you also have a weighting curve which is used to give single figure index. So there's index also which is developed for this purpose. Which takes into consideration how the sensitivity of human ear is, the range of sensitivity which is there. So looking at how it is really measured, the characteristic where you characterize noise over time. So if you think of noise is never steady. It's not really very like uniform across. So whenever this noise happens, it rises and it falls, and it also depends on the activity that is taking place in an area. So there might be a siren which might go up and down. There might be a bang which happens. So there's a variation in the intensity, and it would vary with the time. It would vary with the intensity. And the key measurement index which is used for the environmental noise is equivalent continuous noise level. So this LAEQ is a national steady noise level, which is a consistent noise level, which over a given time would provide the same energy at the same varying noise. So it is calculated by averaging the sound pressure or power or the intensity measurements. So you average that out with certain assumptions that you will have more biasness towards the louder noise events, and converting the average into decibel scale. So you would take more towards the louder noise side, and then you would average it into decibel scale here. So most environmental noise meter index, you can read directly, and you have this LAEQ which is being mostly provided, and the benefit of this is that it takes into account of the energy and the duration of noise events, and it is said to be a very reasonable indicator of like how people respond to noise, and it has been acceptable for the wide range of source as well. Now, looking at the factors influencing noise impact. So looking at what are the factors which really influences the noise impact, there are physical factors which influence how much effect a sound will have upon a potential affected receptor. So what's the amount of sound, and the level of other sound which are also affected by the receptor. So what's the intensity of the sound, the original sound, and then what are the other sounds which might affect the cumulative impact which it would have over the receptor. So one is the physical factor of the sound, and then the other sounds which are present in a place. And then also depends on the context. For example, a person coming from a rural background who has less exposure to the hustle and bustle of the urban area would have lesser tolerance compared to somebody coming from a very noisy place, urban area. So that way context also varies, and you would see that OECD has recommended different noise level for the urban context, suburban context, and the rural areas. So the another factor you see that with the increasing distance from the source of sound, so from wherever the sound is coming, as the distance increases, level of noise from the source decreases. So the level of noise will decrease as the distance would increase. So the way the sound will reduce or attenuate would depend on how the dispersion of energy is happening, which form it is happening, the geometry of dispersion of that particular energy. So as the distance will increase, and in which form it is spreading, and then how far it is going, it would all determine the strength of the sound. Further, we see that you will also have different ways the wave expands, like there might be variations in the expansion pattern of the waves. So if you have a point noise source, then the sound would go in form of a sphere in the increasing radius. The radius will go on increase, and then the sound will go on decreasing in the scale of 6 decibel in the sound pressure, as the reduction of 6 decibel will happen with every doubling of the distance. So likewise, you will also see a variation in the expansion pattern, like when the source of sound noise is linear line source. If you see, like you have roads and railway track, which we talked about. So if that kind of source is there, so that the wave pattern would be again different, and there would be, the reduction would be 3 decibel per doubling of the distance. So the reduction is less in case of linear source. So now also the other factor which would influence is the presence of obstructions. So what kind of obstructions are there on the way of noise? So whether the propagation path from where the noise is traveling, are there any obstructions or not? So the obstruction could be a large building, there could be a wall, there could be a fence, or there could be a mound which are obstructing. So the line of movement of this noise. So it would also depend on that. And usually it is said that trees do not work as an effective barrier, so they do not really stop the noise movement. Other, you also see that what kind of ground surface is there would also affect how the noise is traveling, and depending on how hard is the surface, if it is acting as a reflector, then the noise may further increase, or if it is acting as an observer, observing material like soft grounds where you can have crops, grasslands, and so on, so then it would absorb and it would reduce the intensity of the sound. And there would like apart from these effects, even the climatological effects would also play a role in how the noise travel. So one needs to look at the meteorological data as well, how the things will affect. So usually it is seen that whenever the temperature increases, then the sound waves tend to go more towards the ground level, and then we feel the elevated noise. So we feel increased noise. So during summertime, even when there is quiet, you would have more perception of noise. Or further, we see that wind speed and direction can also affect the noise level. There are guidelines. IFC provides, IFC performance standard provides international benchmark for environmental and social risk management. And you can look at PS 1, 2, 3, and 6 for these guidelines. And we have already seen some of the guidelines in our legislative time also, as well as you would also see the CPCB guidelines which are provided. So that was the first key conceptual understanding. Now moving to the second part, we see the scoping and baseline studies. So looking at the scoping and baseline studies, how do we undertake that? So when dealing with noise, what do we do at the scoping stage? So usually we identify what are the potential sources of noise, from where you need to identify from where all the noise will come in your study area. And you need to identify who all are going to receive those sound, who will be the receptors of those sound, well, who are the people, what are the sources likely to be affected because of the kind of development which you're going to undertake there. So further, apart from receptor, apart from source of noise, you also look at the areas from where you're going to monitor the data. So where all you will monitor, where all you'll place the equipments and regularly monitor the noise level in that your study area. And you are also required to check the national and international guidelines which are available for your study area and your subject domain. So you need to refer to that as well in the scoping stage. So here in the image you can see this case study will be referring here for the line source here. We're looking at the corridor transportation project here. I'll be sharing the link for this. We'll be sharing this file to you. So the Federal Highway Administration, they have developed a noise abatement criteria, NSC. So in this particular study, you will see that they are using this reference, and within this reference, they would be placing all their study finding, impact, and assessment. So you can see different categories, activity criteria, and you may pay attention to the unit they are using, and then evaluation location where they're going to evaluate the exterior or the interior, and then what kind of activity has been happening there. So at the baseline study level, we identify like what information is already there. So you need not collect all the information. So what information is already there, you can take it as a secondary data source. And then what all data you need to collect, collection of any on-site data. So you need to judicially decide upon the locations from where you are going to collect the data. And one also needs to take care what kind of changes will happen in the baseline condition in future and because of your project. So that also needs to be taken into consideration. And you need to identify potential source of noise, and you need to undertake a very detailed project analysis. You have to undertake, and these project analysis has to be taken on site, your project area, as well as off site. So wherever the recipients would be, so that also had to be taken. And then you have to take at the every stage of the project, like during the construction stage, operational stage, and decommissioning stage. So you need to determine the characteristic of the noise source. So what is the characteristic of it? Whether when we say the characteristic, whether it's continuous or it's like coming intermediately. So what kind of noise source is that, and at what time it comes, what's the duration of it, and what's the tonal characteristic of that noise, and all those parameters have to be seen. So in the example here, you can see from the same case we have picked up. So you can see a construction equipment type, typically noise level emissions. So here they have taken during the construction phase, depending on what kind of equipment. You can see the pile driver, jackhammer, tractor, road grader, backhoe truck, and so on. And then look at the noise level, which they have created here from 70 to 100. In a decibel scale, you can see here. So that's how they are presenting their information. And you see that during the scoping stage, each source of impact you need to consider, and you need to take a judgment like what needs to be done. So you need to determine what kind of detailed assessment would be required, and then and where all you can work out without detailed assessments, and and you also need to decide like what will be the significant impact beforehand, so that you don't invest in studying unnecessary details which will not have significant impact. So this will, and whatever you're deciding, what areas to be covered, what not to be covered, you need to explain your decision. You need to justify why you're covering some areas and not covering the others. So here from the same case of low country corridor, so you can see here, that's the project area in the center, you can see. And you can see on the right hand side all the 49 noise study areas which are identified. So you see how intensive those areas have been identified, and you can see all those marked in the red box, so that shows the noise study area, so that they have picked up here. And they have in the report, this is I've taken from an EIA report, so they have also mentioned the noise scale. So here you can see common indoor and outdoor noise levels. So you can see on the left hand side all common outdoor sound levels, and then common indoor sound levels, and then how starting from the threshold of hearing at the bottom. And then you also have the noise exposure hierarchy. So you also see that what are the noticeable noise or not noticeable, which will not have impact. So all those kind of judgments you would be making in your scoping stage itself. So there might be some sound which are noticeable but not intrusive. There's no complaint about it, so there's no specific measurement required. Then you might have noticeable and intrusive, so which can be mitigated, and then you will have noticeable and disruptive, which you need to avoid, and then noticeable and very disruptive, which you need to prevent. So such kind of judgments you have to make. And the key important point in all these assessment, what you'll be doing is to understand the receptors, and for that you might have to prepare, you can also prepare map to identify noise receptors in the areas. And receptors can vary, so you can have different kinds of receptors. You can have local residents, you can have people working in the area or visiting that surrounding areas, and you also need to identify particular land use or activities which are happening in there which are noise sensitive. For that, for example, it could be studios, recording studios, you can have schools, you can have hospitals, libraries, worship space, churches, or things like that. So then those will be very sensitive to the noise. So you need to take care of that. And here in the image you can see how intensive they have made the map, or all the points noted here. If you look at the legend, noise measurement locations of where all the noise measurements have been done, at which locations the measurements have been done. And then the blue color circle, you can see impacted and benefited receptors, so which have positive impact. And then you see the red color circle, impacted but not benefited receptor, and so then you see the green color, not impacted but benefited receptors, and then non-noise sensitive receptor. So you can see how the receptors are there, right of way acquisition, and all those areas, demarcations are there. And the brown color lines, polygons, which you can see are the noise study area. So those pockets they have picked up in the linear source of noise, and then they are systematically undertaking that study. So while at this stage, you also need to discuss with the local authority to identify how your assessment has to be in terms of like how much area you will cover, at what time, what period, what day of the week, what time of the week you would make the recording. So all that has to be aligned with the requirement of the local authority. And you also need to plan the monitoring site, so where you will monitor all the recordings. Usually the most sensitive receptor, like at the school or the hospital, so you locate your monitoring places at those sensitive sites. So that's the basic idea behind that. And you may face problem for identifying sensitive receptors in case of linear development. So here you see that in the case which we are following, that very systematically they are looking at all the pockets and different areas and receptors, how the study has to be done. So here you can see again how they are looking at various areas, all the other roads, railway crossing and stations which are there in the project area. So there are a lot of secondary data available. Usually noise maps are prepared. So in particular to Europe, you would find the directive. They have assessment and management of environmental noise, CPRE, tranquility maps they prepare and keep it. So one can readily take those, and they are very small scale maps, and then they cover large areas, and then just to give a general idea about the level of noise. However, for detailed study you might have to undertake. So I have given you the link from where you can see, explore this, as well as download those maps if you need to see more. And you also see that IEMA also provides summary of research studies, which also show the what kind of variations happen, what kind of noise monitoring data are there. So that also you can see. So you see that there can be a lot of variations when you undertake, when you measure the sound, and those variations can be because of the range of equipments which you are using and so on. So if you look at different kind of equipments which are used for measuring the sound, so you have a microphone which converts changes in ambient pressure into electrical quantity, and it is usually protected by the windshield. Then you have sound level meter, then which gives you information in dB. Then you have analyzer which records noise descriptors. So you have LAEQ, LA max and so on over a period of time. So they provide you that. Then you also have a sound reference sound source which you use for calibrating the equipment. So all these can be also incorporated in one machine only. So sound level meter can have different setting also. So you need to describe that all very clearly, and what weighting you are undertaking for that also need to be described properly in your report. So when you undertake noise measurements, you will look at you would take note of the equipment, what equipment you have used, and you will be also required to tell about the manufacturer and type of that thing, what equipment you have used, and then you also need to record the date and time of that, the weather condition and wind speed and wind direction, and then you also need how you're calibrating the sound meter and microphone. So all that has to be given. Plus you have to even tell about the setting up of the microphone, where you did it, which site you fixed it, and you need to note the locations of those wherever you took the measurements, and what were the criteria for taking the measurements, and you need to adhere to certain guidelines, and you need to report that as well, that which guidelines you adhered to. So whether you were taking continuous for one day, 24 hours, or you took it for 1 hour in a day, so those references have to be given. And you also need to record the start and the finish time of all your recording, and then how did you check the calibrations. So here you can see in this example how the baseline noise data has been recorded for the EIA report. So here you can see in this table you have the start periods, like you have April, you can see what's the start period at 3 o'clock, at 10 o'clock they are ending it, and then 7:20 they are recording it again, and then the sound level which they have recorded and what are the comments there. So you see this is one of the example. So this is about the baseline, what all things you take care of. Now moving on to the impact prediction and evaluation. So the main purpose of impact prediction and evaluation is that you try to find out what kind of changes will happen in the noise level because of the kind of project which is coming up, and these changes you have to look at both the short term and long term. And then you need to, once you understand the changes, you need to understand the significance of those changes, how important these changes are. And you need to understand that predicting noise is a very complex process, and it changes with a lot of conditions. For examples, conditions like what is the existing and future baseline noise levels. So if it changes, then those things might change. What kind of equipment you're using, what's the duration of every stage of construction and operation of your project, and which day and time when in your project what kind of equipment will be used and when it will be used, and what kind of activity will go in the site, and then what's the location of the receiver, how close, how far they are, and how sensitive they are, and then what's the geography, the topography of the area, and then is it offering certain natural sound barriers, and what's the climatic conditions of that area. So these factors will like really influence the quantity, the amount, or the kind of sound which will come from the project area, from the site. So it will be also influenced by how the sound is traveling and how the responder is responding to this noise level. And when you do undertake noise level prediction, you fix like the sound power level at the source, and you predict the sound level at each receptor. So what's the sound level at the source, and then what is the final ultimate sound level at the receptor. And then you would also add new sound level if there are additional levels which are coming there. So in this case, you can see from the same EIA report I have taken, you can see the matrix which has been prepared here. So you see the red color, impacted but not benefited by the potential noise wall. So as a mitigation measure, they are using a protected noise wall, but then these red areas are not getting protected by that, despite they are getting impacted. Then you can see the green, not impacted, but they are getting benefited by that. And then the yellow, you can see not impacted or benefited by the potential noise wall. So they have no difference. So that you can see how they have presented in a matrix form to understand that. Here again, you can see different receivers number 1, 2, 3, and then the noise source, and then how far they are, what's the sound power level at the source, and then what is the distance corrections you're making, and then the screening, how the sound is reducing, what kind of soft surfaces are there, and then what is the predicted sound level at the receiver, and then what kind of ambient noise level is there, and what will be the increase in the noise. So you can see how it has been presented here, and you can take many of these references from the manufacturer of the equipment. So here you can see how in this particular case they have, for their modeling purpose, traffic noise model, they have taken all the classification and then used data from sources which give information. So now looking at how do you really calculate how the sound will reduce because of the geometrical form or the shape of how sound will travel. So when you deal with sound pressure level data, so you have when you undertake when you deal with sound pressure level data, you measure the existing emission source, what kind of source is there, and you take from the standards what it's given there, and then you calculate the distance what it is going to travel, and you take the geometrical, which geometrical dispersion will it take. So in case of point noise source, so when your source is point source, when you have an industry or any construction site, you take it as a point source. So for that, your